Hello everyone, my name is Krishna Prasad and I am an Electronics and Communications Engineering student studying at Christ College of Engineering in Alcuda, and today I'll be talking to you guys about an FM receiver module that I made as a part of my analog communications project. So let's get started. Now right off the bat, one thing that you notice about this project is how weird and unconventional it looks. As you all know, due to the COVID-19 pandemic, all cities have gone into total lockdown, so there really wasn't any option of going outside and buying parts for the project. So all parts used for this project are completely recycled and stuff that I found laying around in my house. Now let's take a closer look at how this actually works. Let's start off by looking at the components used for this build. The main component of this build is the RDA5807M FM receiver module. It's a fairly common module that you can probably find in cheap Chinese radios or alarm clocks. It uses CMOS logic, so it's extremely power efficient, using only about 60 milliwatts of peak power. Combine that with the 3600 mAh power bank that I used to power it, and you're looking at more than 200 hours of playtime. The chip supports a frequency band of 50 to 115 MHz. It also has support for RDS. Now what is RDS, you may ask? RDS stands for Radio Data System. It is basically a communication protocol that is used to embed small amounts of digital information into the radio broadcast. For example, when you're listening to the radio in your car, you might have noticed the name of the FM station being displayed in the stereo. So the name of the FM station is being broadcasted alongside the audio using this RDS communication protocol. Now speaking of communication protocols, this FM receiver module uses I2C communication to communicate with the Arduino that is controlling it. The LCD display that I use also has support for I2C, so this basically means I can control both the FM receiver module and the LCD display using just two wires coming out of the Arduino. So those were the main components used for the build. Next, I needed some sort of switch or button that I could use as the input. Luckily, I found this handy little remote laying around from an old radio control toy. It has two joysticks, and these joysticks basically act as two-way switches, so I could use this to give input to the Arduino. You will also need a female out stack to get the output audio, and you will also need a long piece of wire to use as the antenna. Let's take a look at the circuit diagram. We have the Arduino Nano over here, we have the FM receiver module, we have the LCD display with the I2C converter, we have the power bank and the two-way switches representing the joystick. The 5V regulated output from the power bank powers both the Arduino Nano and the LCD display. The 3.3V regulated output from the Arduino Nano powers the FM module. Now, as I had mentioned earlier, both the FM module and the LCD display uses I2C communication. And for that we need two pins, SDA and SCL. And as you can see from the circuit diagram, the SDA connects to the A4 pin and SCL connects to the A5. Next we have the two joysticks connected to the A0 and A1 pins of the Arduino Nano. One of the terminals of the joystick is connected to ground and the other terminal is connected to the 3.3V. So basically, when the joystick is in the up position, the Arduino receives a 3.3V input. And in the down position, the Arduino receives a 0V input. Now, in terms of the basic functioning, the Arduino basically tells the FM receiver what to do. It tells the FM receiver to receive a particular frequency or change the volume and so on and so forth. And the relevant display is displayed in the LCD using the same I2C lines. Now let's move on and see the device in action. So I had the receiver hooked up to a soundbar over here, and as for the antenna, I'm just using a long piece of soldering lead. To start the device, you just hit the start button on the side, and as you can see, the display turns on. The radio starts out in the preset mode, where you have pre-configured frequencies of radio stations. You can browse through the stations using the right stick. You can go to different menus using the left stick. If you want to change the volume, you go down, and now you can control the volume. If you want to change frequencies manually, you can hit the left stick down again, and now you're in the manual mode, where we can manually go through frequencies and test them out. And there's also an auto seek function which can search frequencies for you and find the stations. That's it.
Now let's have a look at the RDS capabilities of the FM receiver. Now, in order to receive RDS information, it is important to ensure a strong FM signal. However, since I live in a pretty remote area, only Club FM seems to have a strong enough signal. However, in the cities, RDS information will be available across all FM stations.
So as you can see, if you have a clear reception of the FM station, for this case it's Club FM, you can get the RDS information on the display. Now as for the extra features, you have this adjustable LCD display mount, which I made using an old webcam mount. It's powered by a power bank. You can see the battery status if you press this button. You also have the option of charging your phone through this USB port. You can also program the Arduino Nano using the side port. And that's about it. And that concludes the FM receiver project. Hope you guys enjoyed the video and found it useful. If you have project ideas of your own, try implementing them and sharing it with your friends. This lockdown time is a great opportunity to learn new skills and help others improve their skills too. And on that message, I end the video. Thank you.